Okay, so for this one, you're given a few pieces of information. You have integral from 2 to 5 for your function is 16. Integral from 5 to k is -6. So these are two things that are just kind of like given to you. I'm going to bypass those real quick. They're just values we were given. And then we're told integral from 2 to k f of x plus 2 equals 36. Oh, I have typos on there though. I only just realized this right now. I looked over this thing like 6 times and I only just caught this. What do I not have on there? I don't have dx on any of them. This should say dx there. I'm really sorry. Because I have a couple other typos I'm going to tell you about on the other page, but I caught those ones. I did not catch that one. I'm really, really sorry. There, I fixed it now though. All right, so let's look at this one because it's got that +2 in it. We're going to separate it into two different integrals. So we're going to have integral from 2 to k f of x dx plus integral from 2 to k of just the 2. So we separate it into the f of x and the 2. And we're told that that all equals 36. Because it wasn't just an f of x, it was an f of x plus 2. So do you see how I separated it? Are we all together?
Yes.
There, okay. So this one we can actually evaluate using the other two pieces of information from 2 to k. All right, follow me on this. If you go from 2 to 5, and then you go from 5 to k, you really went from 2 to k. Good. So if you add those together, 16 and -6, 10. So this amount is 10 plus, and then this one we're going to have to do fundamental theorem of calculus. Antiderivative and then upper boundary minus lower boundary. So what's your antiderivative of just 2? 2x, good. Such that 2 to k, and then this whole thing equals 36. So this would be 10 plus, and then we're going to do upper boundary minus lower boundary equals 36. I just kind of set it up blank. What would you get if you plugged in k? Yeah, just 2k, substituting the x for a k, and then minus 2 times 2 is 4. I'm gonna have to come over here. So this would be 2k, 10 minus 4 is 6. And then you're just solving that like an algebra 1 problem. So subtract 6. And k is 15. So you're using your integral properties. From 2 to k, and then from 2 to 5, and then from 5 to k gives you from 2 to k. And you kind of just use what you're given to figure out what you're missing, is what we did there, and then solved it. All right, so this one, it says a and b are positive numbers. So when we talk about a, we're going to have to put a negative in front of it. Why? Below sea level. All right. So we're going to write an expression for this awful looking thing. All right, integral from -4 to 3 f of x dx. So that's the whole thing. From -4 to 3, how would we write that? Good, b minus a, or -a plus b if you want to go left to right is how I would put it, but b minus a is perfectly fine, right? Integral from -4 to 3 is the whole thing. And then it says -5 times integral from 0 to -4. So watch me point to this. If you go from 0 to -4, you're going backwards. Good, because this would be -a, but if we go backwards, it would be +a. And then you just put the like terms together. So -a and -5a, be -6a, and then plus b is your answer. You're just putting that all together. You had Delta Math that was like that, right? They gave you like what the little bumps were worth, and then you put it all together. Okay. What does this mean? It's been a while since we looked at that. Prime. That's right. You're my class that says prime. But what does that mean? Second derivative. Good. Okay. So what is a possible equation for f of x? We're going to have to do an antiderivative twice. Okay, good. So if we go backwards once, we'll get f prime. And if we go backwards again, we'll get f of x. As a heads up, you know how you put plus c at the end of this? We're going to end up with two constants because we're going to do it twice. I'm going to call one of them C1 and the other one C2. Do you get me there? Because they're different. Okay. So antiderivative for sine, what you think? Negative cosine minus, all right, antiderivative for 5x Good, 5 halves x squared, and I'm gonna put plus C1. Again, the reason I'm calling that constant 1 is because when we do it again, we're gonna get another constant. I'm gonna call that C2, so that they're different. All right, antiderivative of negative cosine. It would be negative sine, good. Minus, okay. Now you would want this to be a 1/3 x cubed, 1/3 x cubed. But you have to multiply a 1/3 by a 5 half. Good. So 2 times 3 is 6. So 5, 6. I'm going to see if you guys get this one, because you usually impress me. Yeah, it would be C1x plus C2. Now, as a heads up, because I can't remember how they wrote this on the multiple choice, but they can make up whatever numbers they want for C1 and C2. So if one of the answer choices says negative sine x minus 5, 6x cubed plus 3x plus 7, that's the answer. Do you get what I'm saying? Like they can put whatever numbers they want in for that. I don't really either. I'm just letting you know. All right, antiderivative for this one. We 1/6 x to the 6 minus 3 halves x squared plus c. Good news, you can't forget the plus c when it's multiple choice. So you cannot mess it up. All right. This one, that really means x to the -4th. I'm going to write it. If you're able to just hold that in your head, that's fine too. You have to make it less negative. So x to the -3, and so out front is a -1/3 plus c. This one, I'm going to distribute the 2x through there before I do the problem. So if I'm not doing the problem, I'm going to keep the integral and I'm going to keep the dx. We're just rewriting it. So if you distribute, that would give you 2x cubed minus, now this is x to the 1/2. So 2x times x to the 1/2 would be 2x to the 1.5, which would be 3 halves. You have an x and then an x to the 1/2. All right, so antiderivative. This would be 1/4 x to the 4th, but you have to multiply a 1/4 by a 2. Be 1/2, good. And then here, if you add 1, you would get 5 halves. That means you would want a 2/5 out front, but there's already a 2 there. So 4/5, good. And then plus c. Again, I'm going to need to rewrite this one first before I do the problem. So I'm going to keep the integral. I'm going to keep the dx. You're going to divide both of these by that x to the 3rd. So x to the 6th divided by x to the 3rd. That would just be x to the 3rd. And then we would put minus what? Yeah, good, perfect. Then we're going to do the problem. So antiderivative would be 1/4 x to the 4th. Now here you need to make it less negative, so it would be -2. What would you want to put in front of that? It would be a -1/2, but you have to times that by a -7, so +7 halves, good, plus c. Now I left these alone, but do you understand that these are negative exponents? They would go back down to the denominator. I'm just bringing that up because if the answer choice put them in the denominator, I want you to be able to pick the right one. You get what I'm saying? Like, do you need me to show you how to do that? Like, this would be -1/3x cubed. Like, it would look like that. Do you get what I'm saying, guys? Okay, I just want you to get the answer right. My goal is for you to get the answers right. All right, fundamental theorem of calculus. You do what we just did, but then it's upper boundary minus lower boundary. All right. You have to make this. Oh, and I changed some of these boundaries. I'm sorry. When I went through and did this, these ended up being like particularly awful. So I changed some of the boundaries to make it better. Can you make this one 1 to 4? And make this one 1 to 2? And make this one -3 to 3. And I'm sorry, like when I go through and I just kind of put some numbers in, and then when I went and worked it out, it was like truly awful. And I was like, here, let me fix this and make it a little bit better. Trying to help you out. All right. And make it more similar to the test. So you have to make this less negative. So instead of -5 halves, it would be negative 3/2. So out front, you would put negative 2/3, such that 1 to 4. Now I'm gonna rewrite that because I don't really want to do 4 to the negative 3/2. This is kind of what I was talking about, the negative exponents. When you rewrite that, it's gonna go in the denominator. And it would be a square root of what? X to the third, good. And then I'll evaluate it. So I'm just kind of like doing my algebra first. So upper boundary minus lower boundary. So let's see, 4 cubed. 64, square root of 64, 8 times 3, 24. Negative 2/24 be negative 1/12. All right, and then when you plug in 1 cubed is 1, square root of 1 is 1. So it just goes to negative 2/3. Now you have to fight your way through that because that's not going to be an answer choice. It's multiple choice. All right. You have to make them both 12ths. So this would be negative 1/12 plus 8/12. So 7/12. You guys are really good with fractions, though. Every time I give you a fraction problem that I think, oh, this is going to be awful, you guys do great with it. So I'm not worried about you there. All right, this one, again, we're going to need to rewrite it before we do the problem. So keep the integral, keep the dx. We're going to divide both parts of that by the x squared. So we have 2 separate terms. So it'll be 2x to the negative 2 plus, now what do you get if you have x over x squared? It would be x to the negative 1. I'm going to write it like this, though, because that is one of our like special patterns. So doing your antiderivative, you have to make this less negative. So it'll be x to the negative 1. And you would put a negative out front, but there's already a 2 there. I'm sorry, say again. No, the only free response ones are the ones in the back, and I labeled it. So it's and I did those first with you because I wanted to make sure we got to it. Yeah, all the rest of these will be multiple choice. All right, what's your antiderivative for 1 over x? ln x, good. Such that 1 to 2. And I would also rewrite this. I'm just going to erase it and fix it. You can rewrite this as negative 2 over x. And again, if you're able to just hold that in your mind, that's fine. I'm kind of not, though. I need to rewrite it. I need to be able to see it. And then upper boundary minus lower boundary. Well, I think I'm going to be able to finish every single one of these. That'd be great. Oh, bless you. All right, so if you plug in 2, that's going to give you negative 1 plus ln of 2. You can't simplify that without a calculator, so just whatever. And then 1 would give you negative 2 plus ln of 1 is 0. And then we just need to go like one step further. This would be negative 1 plus 2, which would give you 1. So 1 plus ln of 2. Again, I just want you to be like, it's a sad day when you can do the problem, but not pick the correct answer, you know? All right, antiderivative for this one. What do you guys think? Yep. 5 over 3 x cubed, good. Minus x squared, good. Such that negative 3 to 3. So upper boundary minus lower boundary, you're gonna have to fight your way through it the whole way. All right. If you plug in 3 cubed, we're doing the upper boundary. Yeah. So 3 cubed is 27. 27 divided by 3, 9 times 5 is 45. I just didn't want to do 27 times 5, but yes, in theory, that would give you the same thing. All right, minus 3 squared is 9. And then if you do negative 3, you're just going to get a negative 45 there. But this will still be a plus 9 because when you square something, it's going to turn positive. And then you can get through this whatever way you want. I usually distribute the negative first, but it comes down to personal preference.
I have a question.
Oh, minus. I'm sorry. Yes, I'm sorry. Thank you. In my head, I was like, well, when you square things, they're positive, but then it was subtraction. I'm sorry. So then this would be plus 9. So the 9s cancel out, right? Okay, those are gone. 45 and 45 is 90. Cool, we're gonna be able to get this done. It's awesome. All right, antiderivative of cosine. It's just sine. And that's because derivative sine gives you cosine. All right, so we're gonna do upper boundary minus lower boundary. In your mind, think of your pi over 6. What goes across from the pi over 6? The other one. 1/2. Sine of pi over 6 is 1/2. What's sine of 0? 0. Good. So the answer to the whole thing is just 1/2. All right. Using the values in the table. As a heads up, they like to do this. They will give you a table that has way more information than you need. So you will not use everything that's in there. Okay. Antiderivative of f prime is just what? F of x. Good. You're like going backwards. And then it's such that 3 to 7. It's literally your fundamental theorem of calculus. That's all that is. And then it's upper boundary minus lower boundary. So f of 7 minus f of 3. And then you just have to pull those numbers from the table. So you aren't going to use this row at all. They put it there on purpose to confuse you. Okay. What's f of 7? -1. And then f of 3. Good. It would be +8 because minus negative. And so 7 is your answer. Cool. And then the last thing we did was average value. Now it says find the average value for this function that's in the first quadrant. In order to get your boundaries, you have to know what that looks like. So we're going to have to graph it. We'll do this pretty quick though. If you plug in 0 to this, what do you get? 0. Good. The origin. You have to see how far it goes though. They don't tell you. If you plug in 1, you would get 3 altogether there. If you plug in 2, you would have 8 minus 4 is 4. If you plug in 3, you're going to have 12 minus 9, which is 3, and it starts coming back down. So if you plug in 4, you're going to get 0. This is your parabola, and that's the part that's in the first quadrant. So here's the whole point. What are your boundaries? That's why we did that. 0 to 4. Okay, so out front, you would have 1 over 4 minus 0 because it said average, and then integral 0 to 4 of that function. So they just didn't give you the boundaries. You had to find them yourself. And then you just work it out. After that, it's just like do this problem. So you got a 1/4 out front, antiderivative of 4x. Good. 2x squared, good, minus 1/3 x cubed, perfect, such that 0 to 4. Now it would be upper boundary minus lower boundary, but what would you get if you plugged in 0 for these? 0. So really all you need to do is plug in 4, because then it would be minus nothing, all right? So if we plug in 4, 4 squared is 16, double that, 32, minus 4 cubed is 64, so that's 64 thirds. Now, again, you have to keep going because it's multiple choice and that won't be a choice. You can do this however your brain does it. I would distribute the 1/4 though. That's what I would do. 1/4 times 32 is 8. And then when you do 64 divided by 4, you get 16. So the reason I choose to distribute first is it makes the numbers smaller. If you don't have a calculator, you want to keep the numbers as small as possible. All right, how many thirds is 8? 24 thirds minus 16 thirds is 8 thirds. All right, last one. The average value of a function on the interval -1 to 4 is -10. All right, let's set that up. What fraction would go out front? Stick with me, this is the last one. Why is it +1? Because negative. Good. Subtract. Perfect. Integral -1 to 4 f of x dx, blah, 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 is -10. Now, as a heads up where we're going here, you want to multiply this to the other side. So this is 1/5. You would multiply it over, multiply a 5 over. So from -1 to 4, you get what? Negative how much? 10 times 5, guys. 50. There we go. Now we're going to do the next one. It says the average value on the interval 4 to 7. So what fraction would you have out front? 1 over... Good. It would be 7 minus 4, which will be 3. Integral 4 to 7 f of x dx. What do they tell us that one is? 6. We want to do the same thing there, though. This is a 1/3, so you would multiply by 3. So what do you get on the other side for that one? Good. Find the average value on the interval from -1 to 7. Okay, so what fraction would go out front? 7 plus 1. Now, come with me on this. It would be integral -1 to 7. Integral from -1 to 4 is -50. And then integral from 4 to 7 is 18. So integral from -1 to 7, yeah, you would add those together and get -32. That's why they gave those to you. So from -1 to 4 and then from 4 to 7 gives you from -1 to 7. All right, so what is that? 1/8 times 32, -32. -4. 32 divided by 8 is 4.